All right, guys. I think we're live.
But
Let me try
yeah,
to
I mean,
call
it's
Gary.
really just this. Really is the whole world just runs on this popularity engine.
He's already flicking me off.
The person whom you're trying to reach is currently unavailable. Please leave a message after the beep.
I'm live rooming. Don't think that'll work. Yeah, I have to be running Skype on this computer, so wait till I'm running Skype on this computer. There's no point in me answering Skype on the wrong computer. Well, there might be no point. No, okay, good, it ended. Alright, so I'll close the email. And then I will open Skype. We'll see if that blows it up. We'll see if that kills this room. Internet, Skype. Here it is. And such. Alright, so let's see what happens. Okay. So I'll call him back and see if I can't have access to my camera because I'm using it. So you can't do that. Yes, I'll accept. Alright, so there he is. Should I just call you? No, you shouldn't. Alright, so I'll close this room and then call you back. Yes, if you're listening.
All right, guys. So Gary is gonna be calling me back
See if you
soon.
can
Sorry that
access my
took some time
camera
to
and
whatever
then
the
see if
intro.
this works. Alright, so this room is dead, and we'll see if Zachary has a room open on his channel. Okay, we are live on his channel. Okay, then back. This room is now closed,
I guess
and we're moving over there. Post a link to your channel first. That's what we'll do. We'll leave the link here. So post a link to either your channel or the video link.
I guess we're still waiting, guys. Sorry
If you're
about this.
live, post the live link, which is that little arrow at the bottom near end stream. That gives you the link. If you're still there. Or you should know where it is. But yeah, post it in the chat here, so then people who show up will know where they should go. Sort of. Maybe. They probably won't be able to figure it out. Probably won't make any difference at all. Yeah. It'll help one person or something. And he'll be an idiot. So it won't matter. Alright, well, you're not posting the link. So I will just close this room and then Skype and see what happens. Alright. So anyway, till the next time and such and so forth and whatnot. Sorry if this was practice. And I probably should just delete it because it's really bad practice actually. But anyway, till the next time. If there is
I don't know if you guys can hear what he's saying. I have no idea how YouTube Live works or anything. But looks like he's calling me now. So time to respond.
Alright, the camera still looks like shit, but it'll have to do. I like being in the dark. Hello, Zachary, are you there?
Can you hear me?
Car, yeah, so car. Sorry, I gotta, yeah, you can tell me how to pronounce your name, that'll help.
Zohar would be fine, I guess.
Alright, and your last name is?
Kohevi. Cohavy, yeah.
Alright, well, I just wanted, it's a co thing, okay, so,
Yeah.
Kohevi. Zohar Kohevi, okay.
Are you able to see it?
Not at the moment.
1 second, I guess.
Yeah, it's okay. The good thing is we can share screens on Skype, which is really a nice feature. So that might be helpful because we can go to a mutual drawing board.
That'll be good.
And then we can draw crap on it. So if you go to a site called well, yeah, I'll send you the link. That's what I should do. Where do I get the damn link from? No, I don't want to do that. Oh yeah, I want to add a person. Okay, so I send this link to you. All right, and then you'll be on the same drawing board as me. So if you can run a browser at the same time, that'll work.
It doesn't look like I can turn on my video for some reason.
Okay, well, we don't have to have it, but you can fiddle with it for a little bit because I'm going to send you a message here if I can find where the messages go.
Yeah, I think a drawing board is fine.
Yeah, here it is. Open conversation. All right, I'll pop it in there. So I post this. So if you go to this board, we both can draw on the same board.
Wait, where did you post that? It just came up on my screen, but
Yeah, it's a AWW app. You know, it works in any browser. So if you have a web browser open, it will go to a board where we both can draw. So we can both draw at the same time on the board and both see the same board. So when we're talking about something, see, I just drew a messy line.
oh, that's pretty good. Okay, I think I'm opening it.
Yeah, so you should be able to see the stupid line I just drew, and then I'll put another stupid line, and then I'll undo that because it's ugly. Yeah.
I just drew a bit too. You see
Did
it?
it work? Yeah, look at that. That's pretty cool, right? Okay.
Amazing.
Okay. Right. So that's helpful, and then we can share that screen on Skype. You can share your screen, and then one of us can display that board. So since you don't have a camera, you might as well display your board. So
I'm displaying like your video, like the video of you talking, small on the screen, and then the video of the drawing board is going to be big. Is that fine? And then
yeah, that's fine. Yeah, whatever works. If the drawing board is visible, then we're done. Yes, I think it's technically fine then.
Okay, great. I guess we should get started then.
Okay, so let's undo the slop. You have to undo your slop. I can't undo your slop. There's a little arrow going backwards as you undo.
Yeah, I got it.
And there's also an erase function where you can clear the whole screen. So anyway, you'll figure it out pretty quick. It's easy. Color changes, tool changes are pretty simple. So
okay.
And you can also dump images in. So if you want to put an image in, like a JPEG or something, you can just drag it in.
Oh, that's good. I might do that.
Yeah. Okay.
So.
Yeah. Next time I'll fix the settings on my camera before I start, and then you'll have a better camera image. But I can't. Once I'm in, I'm stuck with the camera the way it is, I think.
Yeah, I don't know if I'm able to import the. Do you have those images that I sent you by email?
I have them, but not on this computer, actually. I don't want to open my mail program because it might blow things up with Skype going in my browser and blah, blah, blah. So.
Okay, I think we could probably make it.
Simple enough. They're on the website. So, frankly, we just have to. If you go to my website, they're right on the website.
I think it's fine because we could just. Maybe
the magnetism one is, So if you have the copies of the images, just drag them into the drawing board and they'll open.
Yeah, I'm just not sure that I have the copies of the images, or I'm not sure where to find them other than my email. But I don't want to open my email because it's recording my screen. I'll see if I can find it real quick.
Well, it's not critical. I know the image, so I could redraw it. Simple enough.
Yeah, maybe we should just redraw it. The audience could see it right now because I'm on your website.
Right. Okay, that's good enough then. So it's down at the bottom, so that's fine. As long as they can see it, I know what it looks like. Well, you can see from one side the force is going in, and that's supposed to illustrate the force, the arrows going in in the different colors. So the part that you don't seem to get is that there's two kinds of force. There's electron force and proton force. Yeah. And they have two different reactions when they interact. And so the point is that the magnet filters those two forces. So all the red force ends up going out one end of the magnet, and all the black force ends up going out the other end. And that's partly because one end reflects also. So the one end is reflecting everything that goes in that end. So I'll draw a quick picture.
Okay.
All right, quick one. Well, I hope it's quick. So if you think of this as like a proton and an electron, it's the same basic function as plus and minus. So you could say north and south, but it's really plus and minus. So if any blue bit of energy, goes into this into the magnet, it would reflect. So what the world will see is just this blue stuff coming out, because all the blue is going to reflect. And anything red that goes in, say that it's a simpler way to change the color, anything red goes in and ends up coming out the red end. So that's basically where the energy of the magnet comes from. It's taking the field pressure and filtering it for the two colors. So if blue if blue comes in the red end, it ends up coming out the blue end. If red comes in the blue end, it ends up coming, it comes out the red end, and vice versa. So
Okay.
you end up with all the red force, the force that would reflect against protons coming out of one end, and all the force coming out of the other end is going to be the force that reflects electrons. So obviously it becomes a kind of just like an electric dipole, or you could think of it as two monopoles very close together. But it's the same effect. So an electron is going to be deflected by this called the north end, and protons are going to be reflected by the south end, because the force that reflects off of them is the force that's coming out of these ends, because it's a filter. So the universe is made out of forces that are the two colors in a really dense stream of, that's just mixture of these two kinds of force flying around in the universe. And that's what the little picture illustrates, the little cutout on the top of the website. So
what exactly like makes it so that when there's like a lot of blue force bits, it causes like a repelling kind of thing, and then
yeah, well, it's just two interactions, right? There's two kinds of force, 2 plus 2 plus 2 physics, and then there's two kinds of interactions. So if you have an electron and you hit it with blue force, the force reflects essentially. What's really happening is this blue bit's going inside here, and this boat lets this loose. So it's really a 2x change in the overall momentum of the object, because it's giving away this arrow and it's getting this one. So it's making an exchange with the universe. So this goes in, that goes out.
And it's weaker with the red when the red comes in, right? It's like a lot weaker. It might be like X or something.
Right. So when a red force comes in, I can just draw over the blue one and I'll show you. So when a red one's doing the same thing, it's really going to make an exchange. So this is going to go out again. But the key difference is, well, technically it's not going to go out that way. But anyway, what's going to happen is it's like a head-on collision. Instead of the two things going in the opposite directions, they go perpendicular. So they go into the second or the third dimension. So they go left, right, or they go up and down. So essentially, this will be comparable in the sense that the reflection will end up being perpendicular and the motion will be perpendicular. So the object gives up this and it gets this. Okay, if you can get me, if you can see my mouse moving. So it's giving away something this way, and it gains something this way, and this ends up going this way. So it's the same amount of momentum leaving. In the sense, you got one arrow plus one arrow, but obviously it's leaving in the second or third dimension. That is, it's going left and right instead of forward and back, or up, or it could have gone up and down. So the simulations we're only going to work in 2 dimensions for a while, but technically that's how you get into the third dimension. And that's how you get the motor force and all this other stuff. So it's sort of important to pay attention to the third dimension out, 3 dimensions, but frankly you can illustrate it in 2.
Yeah, I don't know how to spell in this thing, but so you're saying that because there's 2, because it's like because the interaction it like exchanges more basically because it's a direct hit kind of, or like it's a direct mirroring sort of. And so that's why it would repel, right? Because there would be like a stronger kind of force between these two objects.
Think of it as of 2 boats. So if I put 2 red boats here, right, and you imagine that these are like boats with rowers in them. And every time a rower comes this way, he's going to kick this guy out. So the guy rowing this way, he kicks out, right?
So this guy jumps in the boat here, and he rows that way. This guy jumped out of the boat, the guy going this way. So can you get that exchange part?
Yeah.
Well, if that keeps happening, so this ends up going right back to here, this boat again, and it's the same thing's going to happen. This arrow is going in, and this guy is leaving. So you can see that this is getting momentum this way, this is getting momentum this way, and as long as this swimmer stays here, he's going to keep bouncing back and forth. And you can sort of understand that's just like two ping pong paddles. And if I have a ball bouncing back and forth, right, that's going to always put a constant pressure, so it's bouncing back and forth forever. Now, if I put those two paddles closer together, it's going to bounce twice as many times, twice as many interactions, twice as much pressure going out this way.
Okay. And
Okay,
that's why it repels, right?
So it repels because the pressure is trapped, and it keeps hitting both of them in the opposite direction. So clearly, all I need is one little force bit to be trapped here, and you could sort of imagine that if I made this distance really, really tiny, that one ball would be bouncing 1,000,000 times a second. So it'd be creating a huge amount of pressure because every time it's making this exchange, theoretically.
Okay, I guess I have a question though, because so if it's happening because like between the two red objects that you're showing on the screen, I guess I'll just point an arrow to show what I'm talking about. So between those two red objects, you're saying that the red force bits are going to be going in between them, right? And that's going to cause the repulsion. But
So they're
isn't
trapped. Yes,
yeah?
they're trapped.
But isn't the opposite going to happen with blue force bits, or what's going to happen with the blue ones?
Well, as I pointed out, the blue ones are going out of the second or third dimension.
I
Blue
think
ones
I got it.
escape. See, the blue ones always escape. Every time one comes in, that goes back out this way.
Oh, I see.
So
Okay.
they can't create any pressure in here. So when you have a blue and a red, so let's say I change this guy's color to red, you can sort of understand that every blue bit might reflect once, but it goes out of the red, and every red bit, right, isn't going to reflect. It's going to go out the side. So all the pressure leaks out. You don't
I see.
end up with nothing in here. So the interior pressure goes to zero, right? There's just zero caught here, and these two things will end up going into each other. Now it gets a little more complicated, but when the thing has motion, right? When this thing is actually moving in a direction, then the likelihood of which direction the force goes out changes. So in the direction it's moving, it will turn towards, okay, the motion will always be against the motion it's already moving, and the force will leave the opposite way, kind of a thing. So it gets a little more complicated when things are moving. But you can understand when something's moving away from you, that means it has more fish. If we thought of it as a school of fish, that would mean more fish are swimming away from you in the school, right? If a school of fish is moving away from you, you can understand that theoretically there has to be more fish moving away from you than towards you in the school, right?
Yeah.
And you're more likely to hit the fish coming towards you. So now most of the fish are swimming away from you. They're harder to hit. You can't catch up to them because they're going as fast as you, theoretically. You know what I mean? So you'd never hit fish going the same way you're going. You only hit fish going the opposite direction. So your likelihood of hitting something when it's moving away from you gets less and less. So the faster it's moving away from you, the smaller it's essentially getting. Its profile, its mass is shrinking right before your eyes. And the faster it's coming towards you, the easier it is to hit, because then all the fish are heading right for you, right? So now the fish are really big and really easy to hit. So I'm just saying there's more to it than just this simple diagram, but it's understandably more to it, you know.
Yeah, I mean, I guess I'm I'm just happy. I think I got it with the repulsion because I was confused as to why, what would happen with the other force bits. But yeah, they just leak out, so that was not that complicated.
Yeah, well, the repulsion gets stronger. It also explains why there's our rule about how strong the force gets is because the closer you bring the things, the more interactions there are, and interactions are the definition of energy, right? So if the ball's bouncing slowly back and forth, you can sort of understand that that's fewer interactions and fewer obligation, less pressure. And it's more pressure, the more interactions. So bringing two things close together is the same as giving the ping pong balls twice as much speed. It's a clear increase in the received energy. Even though you haven't made more energy, you've made the system more energetic.
Yeah. So I have a question. What about the attraction? How does the attraction happen?
Well, because of the rule I just stated, is that attraction happens because there can't be any reflections. And so, and all the force keeps leaking out
yeah. So
both objects.
yeah,
So they're leaking the inverse force, so you never have a bounce back and forth syndrome. So
yeah.
you end up with low pressure between them because everything's leaking out in some, it doesn't have to be perfectly perpendicular, but it's leading out in some direction that certainly isn't the exact opposite.
Yeah, so both of the force bits are going to be like not able to get trapped anymore.
Right. And they're all going to get evacuated, essentially. So, yes, so the two paddles can get really close to each other because the only source of any energy is the energy that comes in from the sides. The other dimensions can add energy, but the rule is they can't add energy in the right direction when they're moving away from each other. So the only way they can add energy is when two things are already moving towards each other, if you get my point.
Yeah, I think I totally understand now. But yeah, that was okay. I think that was magnetism pretty much. I don't know if there's anything else about it. Just the magnet effect.
It's magnetism, but it's really charge. I mean, that's why charges attract and charges repel. And I'm just saying, well, magnets are obviously just doing the same thing, but they're additive. So the trick with magnets is you can stack them on top of each other, right? You can have magnet on top of magnet on top of little magnets, little atomic magnets. Well, and when you do that, you magnify essentially the force of the magnet. The filter gets stronger and stronger the more little magnets you pile on top of each other.
So is the south end of the magnet like more of like the red matter bits, and the north end is more of the blue matter bits?
Well, in this drawing, it is, but obviously, north end is electron repulsive. So if you want to push electrons away, you use the north end of the magnet. So it's electron force. So whatever color you want to give electrons, which I use blue because red is better for the positive. But anyway, the south end repels protons, the north end repels electrons.
Okay.
So it's exactly the same charge force. It's just that, they just don't recognize that charge is a phenomenon that happens between electrons and protons. And whenever it's on any bigger piece of matter, it's always on the surface. Charge isn't something that happens. You don't make a solid giant proton. There's no big protons anywhere. All you can do is put charge on surfaces.
Okay, I actually remember learning this, but
magnets, on the other hand, magnetism happens inside of the whole piece of metal. You magnetize the whole piece of iron, so all the atoms end up lining up. And
what do you mean by lining up? Like, you mean like blue, red, blue, red?
Well, that's what I just showed you here. But yeah, blue, red, blue, red, blue, red. They all end up. The atoms themselves end up polarized because their shape changes. So now they have an electron that's at one end and proton heavy at the other end, in the sense that the electron spends more time at this end. Well, it's not that it spends more time, it's that it's closer distance. So the atoms end up polarized, and then you just stack a bunch of atoms that are polarized in the same direction. So this end becomes blue, and the other end is red, and then you just have a bunch of those atoms end up in the same direction. And when that happens, like I said, they add their effect. The filtering process happens between each one of the atoms, so they end up directing all the blue energy out one end, all the red out one end, and all the blue energy ends up being directed out the other end, and so it becomes a big magnet.
Oh, that's interesting. Do you think there's a way of like explaining how strong different elements might be based on like how many electrons they have and how many protons they have? Like neodymium is like an extremely strong magnet.
Well, I mean, you polarize the atom by basically changing the distance of the orbital. So there's you change the distance between the electron and the proton. So if I make this an electron, I'll draw a proton.
Should we erase some stuff or move to like another screen? Or?
Yeah, we can just clear here. I'll clear the whole thing.
All right.
There. All right. So the difference is, I got to put the pen back on. Okay. All right. So you have an electron and a proton, and all you're really saying. So when they're in one kind of state, all right, their profile in different directions are going to be different. So if you're looking at it from this direction, it's going to look like it's an electron. If you look at it from this direction, this direction would be an electron. In the other direction, it's going to look like a proton. That is, it's going to look positive from one side and negative from the other side. And what they're really saying is there's a distance you can move this electron. That is, it could be here. Turn that red. If I move the electron out further from the proton, you could sort of see from this direction, it could now look less red.
Are you drawing something? Are you drawing something somewhere?
Yeah, I am drawing on the same board. You don't see it?
I'm not sure. Maybe like draw some extra stuff from us so I could maybe see where. It's where all the circles are, right?
All right, well, let's just both refresh the page and see what you get. It should be the same board, technically. So we should both be on the same board again. So you see the line?
I'm not sure what you're referring to because you're not like pointing to it or anything, so I don't know which line.
On the board. What do you see on the board you're looking at?
I see like a bunch of magnets to the left and a bunch of circles to the right. I'm not even sure which one of those I'm supposed to be looking at.
Yeah, well, I cleared the board, so I guess you didn't see it get cleared. So
oh, it doesn't. Yeah, it's not
just
showing.
refresh. Just refresh. Just hit the refresh button on the whole page.
I just did, and it didn't show it cleared. So I don't know why that would happen.
Yeah, I don't know why either.
I guess I'll just clear it myself then and see if that.
These stupid. There's little arrows over here, so I see some little stuff. Maybe this hand thing will do something. No, that's just little. I don't know what any of that is.
I think I might be able to.
Well, we should have been on the same board. We should still be on the same board, so I don't know where. I'll try joining it again.
I just erased everything. Do you see it all as erased, or is it on the board for you? I can try to draw something, and I'll say if I see it.
Yeah, well, I already tried drawing something and didn't see it.
So it's showing you that there's something because my board is empty now.
Yeah, well, that's what I'm saying is mine is supposed to be empty also. I mean, I refreshed the page and it was empty. So, did you refresh the page?
I'll do it again, but I don't think that's gonna fix it. I guess.
Well, it should be the same board. That's all I'm saying. So technically, it should get us both back to the same board.
Yeah, it's weird. I guess. I don't know what to do about that. I think we like disconnected somehow or something. But like it's not updating mine or not updating yours.
Well, I'll just hit the original. I'll just take the board out and make a new one then. But I mean, I don't know why that would not work. That's kind of weird.
Yeah. I guess maybe just make a new one. Yeah, that is kind of rude. I mean, I'm pretty happy with what I've learned so far because I totally understand the magnet stuff now.
All right, so I joined the board and then I copy the link and it should be okay. So copy and then I'll send that to you. I'm just gonna hit this chat thing. Where's this thing? Okay, so there's a new link. Let's see what that does. I will post a cross, a little.
Okay, I see it now. So I guess that fixed it.
Okay, so I guess we can't do the clear board. We have to do the undo button. So stay away from the clear the whole board because that fails.
I don't think I know where that button is even. But.
All right. Well, anyway, the distance between the electron and the proton would be a way of understanding that if I changed how far away this little red thing is from this black thing, you could sort of understand that the closer I make it to your eye, if your eye was over here looking at it, the closer I make the red thing to your eye, the less you're going to see of the black thing, right? So you can sort of understand that if I put the little red thing here, you won't see any of the black thing, right? It'll all be shadow. And if I put the red thing here, you're going to see more of this big rock than you're going to see of that little thing. So that's sort of the definition of polarization. And it's always from some point of view. So it always depends on where you're looking at it from. So if I look at it from this side, it's proton. If I look at it from this side, it could be an electron or a proton, depending on how far away the electron is, right? And obviously, most of the atoms we're looking at have electrons on both sides. So you can understand that if I just make the electrons further away from the nucleus, then I'm going to make it look like it's more negative. Where if the electrons are closer to the protons in the middle of the nucleus, they're going to look smaller, they're going to have less impact, so it's going to look positive. So it's a way of understanding polarization. Polarization is really just perspective.
Yeah, okay. I think I got that. And you think that would be the explanation for why like different types of matter might
Yeah, obviously they all have different. Oh, great! The end is working.
Oh wait, one second. I need to go get the chart. Like I'm doing too much like streaming and Skyping at the same time and stuff, so it's taking a lot of my battery. So I need to go get my charger real quick.
Yep.
I'll be back in 30 seconds.
Okay, I'll take over. Yeah, so just draw dirty pictures. No, I won't do that. Okay, never mind. I really am a childish asshole. What else am I? Oh yeah, jerk. And such. I gotta go find the video. See if the video is accessible. Yeah, that'd be fun. This is that stupid room I was in. Oh, freaking bunch of morons. What the hell is this? Unity.
So I think it might be a good idea. Like I either have to wait a certain amount of time right now because basically I have pet birds who somehow this doesn't happen often, but they got out of the room somehow and got lost in some other room in the house.
Oh, okay. It's no big deal. We did some work here. We know it works this way, so we'll just call it a video, and we can do some more tomorrow, whatever day you want.
Okay, that's probably best. Yeah. Yeah, this was pretty good. I think.
Yeah, I think it wasn't horrible. Okay,
Yeah.
so yeah.
Maybe we could talk about the double slit experiment or something next time.
All right.
All right.
Whatever, your choice. And I'm open to pretty much anything. So anyway, so yes, so goodbye.
All right.
Until next time and such. You can do text, but it's pretty lame.
All right, I'll see you.
Good day. That's it, right? That's Australian talk, right? Yeah.
Sure.
Oh, you're burning down, though. I should have flames on everything because you're burning to death over there.
Yeah, I mean, I guess it sucks that I have to rush and leave really fast, but it was a nice chat.
Yep. Go ahead. Till next time and such.
All
Okay.
right.
Thanks. And.
All right, guys, the stream's over, and I gotta go.